Have you ever wondered why the Earth isn't flat, but punctuated with towering peaks and deep valleys? This question sparks the enigma of mountains, a fascinating phenomenon that has intrigued humans for millennia. Today, we're uncovering the secrets that lie beneath these awe-inspiring structures. Mountains, with their majestic peaks and vast expanses, are not just a sight for sore eyes. They are the result of an intricate dance of geological forces, a testament to the dynamic nature of our planet. But how exactly do they come to be? In this video, we're taking you on a journey into the heart of mountains, exploring the science behind their formation. We'll delve into the world of plate tectonics, the birth and life of a mountain, and so much more. By the end, you'll have a newfound appreciation for these magnificent natural skyscrapers. Prepare to embark on a journey to the peaks of knowledge about mountains. To understand mountain formation, we first need to grasp the concept of plate tectonics. You see, our planet isn't a solid, unchanging sphere. Instead, it's more like a jigsaw puzzle, made up of massive slabs called tectonic plates. These plates form the Earth's outer shell or lithosphere, which is about 62 miles thick. Now, this might seem pretty solid, but it's not quite as stable as you'd think. Beneath the lithosphere lies the asthenosphere, a layer of the Earth that's so hot and under such pressure that the rocks there behave more like a slow-moving viscous fluid than a solid. This layer acts as a sort of conveyor belt, carrying the tectonic plates along on its slow, churning currents. Now, these tectonic plates don't just slide around smoothly. They grind and jostle against each other, building up tension. Sometimes they even get stuck, but the forces pushing them are relentless, and eventually, something has to give. When the tension becomes too much, the plates move suddenly, releasing all that pent-up energy in an earthquake. But it isn't just earthquakes that result from this tectonic activity. Volcanoes can form where one plate is forced under another, melting into magma and then erupting back to the surface. And then, of course, there are mountains. Mountains can form where two plates collide head-on. Instead of one plate sliding under the other, they can both push upwards, crumpling and folding the Earth's crust into towering peaks and deep valleys. But what about the plates themselves? Well, there are 7 major tectonic plates, and countless smaller ones. They all move in different directions, at different speeds, and with different results. Some move apart, creating gaps where new crust can form. Others move together, causing the crust to buckle and fold. And some slide past each other, causing the ground to shake and shudder. So, in essence, our Earth is like a giant, ever-changing jigsaw puzzle, constantly being reshaped by the movement of its tectonic plates. And it's this movement, this constant, never-ending dance of the Earth's crust, that gives rise to the breathtaking landscapes we see around us. So the movement of these tectonic plates sets the stage for mountain formation. Now that we understand the role of tectonic plates, we can dive into the process of mountain formation. In essence, mountains are born when the Earth's crust experiences stress, causing it to buckle, fold, or fracture. This stress typically arises from the movement of tectonic plates, but how the crust responds to this stress can result in 3 different types of mountains: fold, block, and volcanic mountains. Let's start with fold mountains. They are the most common type of mountain. Think of the Himalayas or the Rocky Mountains. These majestic peaks form when 2 tectonic plates collide, and the pressure forces the crust to crumple and fold. Imagine it like a rug being pushed together, creating folds and crests. Similar patterns form in the crust, but on a much grander scale. Next up, we have block mountains. These are formed when faults or cracks in the Earth's crust force some materials or blocks to tilt or rise. Picture a massive block of rock being pushed up while the surrounding land sinks down. This process gives rise to steep-sided slopes and flat summit areas, a prime example being the Sierra Nevada range in North America. Finally, we have volcanic mountains. As you may have guessed, these mountains are born out of volcanic activity. When magma pushes its way to the Earth's surface, it can either flow out of the volcano or cool and solidify before it gets a chance to erupt. Over time, repeated eruptions cause layers of lava and ash to accumulate, creating a cone-shaped mountain. Think of Mount Fuji in Japan or Mount St. Helens in the United States. Each type of mountain has its unique formation process, but they all share a common denominator: the incredible power of the Earth's inner forces. These forces, constantly at work beneath our feet, shape the planet's surface, sculpting it into the breathtaking landscapes we see today. Each type of mountain formation is a testament to the powerful forces at work beneath the Earth's surface. Mountains don't just appear overnight, and they don't stay the same forever. In the grand scheme of things, the life of a mountain is an epic tale of transformation. These towering giants of nature are born from the tumultuous movements of the Earth's crust, but their story doesn't end there. They continue to evolve, shaped by the relentless forces of weather, climate, and tectonic activity. Imagine a mountain as a living entity, undergoing changes just like any organism. Following its dramatic birth, it enters a phase of growth. This isn't growth in the way we usually understand it. There's no upward thrust, no sprouting new peaks. Instead, it's a process of sculpting and reshaping. Wind, rain, ice, and even the sun play their part in this. They carve the mountain's face, chiseling away at its surface, creating the ridges, valleys, and ravines that make each mountain unique. And then comes the testing phase of maturity. Here, the mountain's resilience is truly put to the test. The very elements that shaped it now seek to wear it down. Erosion is the great equalizer in the mountain's life. It's a slow, relentless process that grinds the mountain down bit by bit. Rain washes away the soil, wind whittles down the rock, and glaciers scrape and gouge the mountain's surface. Over thousands, even millions of years, a towering peak can be reduced to a mere hill. Yet, it's not all about decay. Even as mountains erode, they continue to be dynamic landscapes. Volcanic activity can add new layers to their structure, while earthquakes can trigger landslides, reshaping their contours. It's a constant cycle of creation and destruction, testament to the ever-changing nature of our planet. The life of a mountain is a testament to the power of time and the enduring nature of change. It's a humbling reminder of our planet's dynamic nature and the transient beauty of the landscapes we often take for granted. Just like living organisms, mountains have a life cycle. They are born, they grow, and they eventually wear away. We've journeyed from the depths of the Earth's crust to the highest peaks, but what have we learned? We've unearthed the enigma of mountains, delving into the mysteries that lie beneath their majestic peaks. We've discovered that mountains are not just static, but dynamic, ever-changing landscapes shaped by the powerful forces of nature. They are the visible evidence of the Earth's inner workings, revealing the processes that have shaped our planet over billions of years. We've explored the basics of plate tectonics, the theory that explains how the Earth's crust is divided into large pieces, or plates, which are constantly moving. These plates collide, separate, and slide past each other, creating the conditions necessary for mountain formation. When two plates collide, the pressure can cause the crust to buckle and fold, creating ranges like the Himalayas. Alternatively, when a plate is forced beneath another, in a process called subduction, it can lead to the formation of volcanic mountains, like the Andes. We've witnessed the birth of a mountain, understanding that this process is not a rapid event, but a slow and steady progression that takes millions of years. It's a journey that begins deep within the Earth's crust, where rock is subjected to immense pressure and heat, transforming over time into the towering peaks we see today. We've also learned about the life of a mountain, acknowledging that even the most formidable peak is subjected to the relentless forces of erosion. Wind, rain, ice, and even the movement of organisms can wear down a mountain over time, a process that is as much a part of its life as its formation. So we see mountains are not just static entities, but dynamic landscapes, shaped and reshaped by the forces of nature over billions of years. They stand as testament to the Earth's long and complex geological history, a history that is still being written. Next time you gaze upon a mountain, remember the incredible geological journey it has taken to reach its towering height,